All right, so today we're going to be looking at the first part of section 2.5, which is zeros of the polynomial functions. The rational zero test, or another name for that would be a rational root test, since zeros, roots, x-intercepts, those are all the same. That is, they all have the same name. So rational zero test or rational root test. All right, so the objective of this section, or this particular part of the section, is to find rational and other roots of a polynomial with integer coefficients. So right below here is the rational root theorem. So it says basically you have some polynomial with integer coefficients. That means the number that is in front of each variable is an integer. That means there's no fractions, there's no decimals, it's, an integer. And we can find the possible, this is possible, that doesn't mean that there are roots here, by taking p divided by q, where p is a factor of the constant and q is a factor of the leading coefficient. So if we're looking at example 1, we're focusing on the factors of the constant over the factors of the leading coefficient. So again, p is the factors of the constant. P is going to be factors of 6. So p is going to be factors of 6. So each of these factors is going to have a positive and a negative value. So a factor of 6 is 1. A factor is what divides evenly into 6. 1 divides evenly into 6. Positive and negative 1. Positive and negative 2 is a factor of 6. Positive and negative 3 is a factor of 6. 4 doesn't go in there, 5 doesn't go into 6, and 6 goes into 6. So these are all the factors of this constant 6. And then q are going to be all the factors of the leading coefficient. So the leading coefficient is 2. So we've got plus or minus 1, plus or minus 2. Those are the only factors of 2. And then what we do is we divide p divided by q. So you want to, so possible rational roots are plus or minus 1 divided by plus or minus 1 would just be plus or minus 1. And then I do this, I try to be organized so that I get them all. So then I keep plus or minus 1 divided by plus or minus 2, which would give me plus or minus 1/2. So then I'm done with this 1 and I move over to the 2. Plus or minus 2 divided by 1 is plus or minus 2. Then I take plus or minus 2 divided by plus or minus 2, which is plus or minus 1. But I already have that factor listed, so I'm not going to write that one. I move to 3. Plus or minus 3 divided by plus or minus 1 is plus or minus 3. Plus or minus 3 divided by plus or minus 2 is plus or minus 3/2. Done with the 3. Plus or minus 6 divided by plus or minus 1 is plus or minus 6. Plus or minus 6 divided by plus or minus 2 is plus or minus 3. But I already have that listed. So these are all my possible roots. Now example 2 says, using your calculator, find the actual, this is really what it's saying, find the rational roots in example 1. So what I'm doing, I'm not finding all the roots, I'm just finding of these, which one is actually a root, which one is actually a 0, which one is actually an x-intercept. That's what all that means. So I'm going to come in here and put this in my graphing calculator. So under y equals, so 2x to the 4th plus 3x to the 3rd minus 8x squared minus 9x plus 6. Just going to double check to make sure I entered it correctly. I'm going to hit zoom 6. And so I'm looking where this polynomial crosses the x-axis. So it looks like it's crossing 1, 2, 3, 4 places. Which one is actually one of these roots, one of these rational roots? So I want to focus over here because I need to zoom in. So I'm going to try zoom 2, which is zoom in. So it's looking like -2. It's crossing at -2 right here. So that's a rational root. This looks like, if you look at here, are there any rational roots between -1 and -2? Well, -3/2, but I don't think that is -3/2. We can check. Second, trace 0. Come over here. Try to find this one. Let's left bound, enter, right bound, enter, enter. Yeah, -1.7320, that's not any of those numbers. That is an irrational number. That's a square root, negative square root of 3. So that's not 1. Over here, that's between 0 and 1. It looks like it's 1/2. I'm just going to double check. Second, trace 0. Left bound, enter, right bound, enter, enter. Yep, 0.5 is 1/2, so 1/2 is 1. And this one between 1 and 3 is not 3/2 because it's more than 1.5. So that's also a irrational root. So the only rational roots would be -2 and 1/2. So example 3, list all the possible rational roots of p of x equals 6x cubed minus 4x squared plus 3x minus 2. So again, my p-values are plus or minus factors of -2, plus or minus 1, plus or minus 2. Q, all my factors of 6, my leading coefficient, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. All the numbers that divide evenly into 6. And then I'll do p divided by q. So rational roots. Possible. So p over q. Plus or minus 1 divided by plus or minus 1, plus or minus 1. Plus or minus 1 divided by plus or minus 2, plus or minus 1/2. Plus or minus 1 divided by plus or minus 3, plus or minus 1/3. Plus or minus 1 divided by plus or minus 6, plus or minus 1/6. Done with the 1. Move on to the 2. 2 divided by 1, plus or minus 2. 2 divided by 2 is 1. I already have that. Plus or minus 2 divided by 3, plus or minus 2/3. Plus or minus 2 divided by 6 is plus or minus 1/3, which I already have. So these are all my possible rational roots. Now back to my calculator to find which one of these roots is actually a 0 or a rational root. Again, the definition of a rational number is a number that can be written as a fraction, thus of integers. Thus, that's where we're coming up with our fraction, our p over q. So under y equals, again, I'll clear that. 6x to the third minus 4x squared plus 3x minus 2. So it's 6x to the third minus 4x squared plus 6x minus 2. And I'm going to do zoom 6. So if you look at that, there is only one root, real root here, and it's between 0 and 1. So of those numbers, which numbers are between 0 and 1? Well, this one's not. This one could be possibly that. It could be possibly this. It could be this, or it could be this one. Well, you can see that it's closer to between 0 and 1. It's closer to 1. I'm guessing it's 2/3, but again, I'm going to just double check. Second trace, 0, enter, enter, enter. 0.666, which is 2/3 as a fraction, so my rational root is 2/3. All right. Example 5, all the possible rational roots. So all the factors of 30, plus or minus 1, plus or minus 2, plus or minus 3 goes into 30, 4 does not, 5 goes into 30, 5 times 6, so 6 is a factor, 7's not a factor, 8's not a factor, 9's not a factor, 10 is a factor, 10 times 3, 2 times what is 30? 15 is a factor, and then 1 times 30, so 30 is a factor. So a bunch of factors here. So factors of leading coefficient. So factors of 1. The only factors of 1 are 1 and -1. So I'm going to take all of these numbers and divide it by 1. Well, if I divide all these numbers by 1, I get all these numbers. So my possible rational roots are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 5, plus or minus 6, plus or minus 10, plus or minus 15, and plus or minus 30. Then we're going to use our calculator. We're going to find those actual rational roots. So let's type that in. So x to the third plus 6x squared minus x minus 30. Again, because this is an x to the third, the most roots it can have, the most x-intercepts it can have is 3. So when we hit graph, the most we can see is 3. There's 1, 2, and 3. And it looks like they are all crossing at integers. So that is 1, 2, 3, 4, -5, -3, and +2. So all of those were all integer roots, which are integers are also rational numbers. So that's the rational zero test or rational root test. So it's really easy as long as you understand how to find factors. So the next video would be on the second part of section 2.5, which is Descartes' rule of signs.